Hello everyone. Welcome to the solution of LeetCode problem 225 named implement a stack using queues. In this problem, we have to implement a last in first out stack using only two of the queues. The implemented stack should support all of the function of the normal stack such that push, pop, top and empty. So here we have to implement the myStack class. In the myStack class, there should be four functions. One is push. That means we have to push element X into the stack. Then we have to perform the pop. That means we have to remove the element from top of the stack and return it. Then there is a top method. That means we have to return the element on the top of the stack. And there is a function named empty. So we have to return true if the stack is empty, and we have to return false otherwise. So I hope you understood the problem statement. Now let's move on to the algorithm. Now we have to implement four of the method, which is push, pop, top, and empty. And in this method, push, top, and empty is relatively easy, but the method pop is relatively complex. So I am explaining the easiest method right now, which is push. So in this method, we are given an integer x and we have to push this x into the Q1. So here we know that the stack property is if we push any element into the stack, it will go in the bottom. Then if we push another element, it will look like something like this. So, and if we want to pop the element, we have to return or we have to erase the last element that we have pushed from the stack. So here, a stack operates in last in first out manner. So which elements appear at the last should be removed at the first. But the queue follows almost a reverse mechanism. Here, if we push any element into the queue, it will become at the first position. Then after that, if we remove or push anything, that means it will be stored in subsequent manner. Now, if we want to remove any element from the queue, the first element which is pushed should be removed first. So the queue follows the first in, first out manner, which is FIFO, and the stack follows the last in, first out manner, which is LIFO. Now let us implement the push mechanism in the stack. So here, suppose in the push mechanism, we are given an integer x. Now we have to add this integer x into the queue. So this is simple. Suppose the value of x is 2. So here we have to add the element 2 into the queue. It is now done. So this is the implementations or the mechanism of the push method. For the push method, we have to simply insert the given parameter to the Q1. Now, the top methods returns the topmost element in the stack. So here, if we want to implement the top method in the queues, which performs similar to the stack, we have to use the back function. So here, if we use the back function on the Q1, it will return the last element of the queue. Suppose our queue has 2, 1, 5, and 4. So now, if we apply the back method here, it will return the last element that is inserted, which is 4. So here, the performance is similar to the stack because if we add 2, 1, 5, and 4 into the stack, the top method will return this element 4. So here, similarly, for the queue, we have to use the back method, which returns the last element. Now, we have to implement the empty methods. So here, the mechanism of empty method is easy. We have to just check whether the element presented in the Q1 is empty or not. Or we can say that the size of the Q1 is 0 or not. If the size of the Q1 is 0, that means we have to return true because the Q1 is empty. Otherwise, we have to simply return false. Now, finally, the most complex method, which is the pop method. Now, as we all know that Q stores the element in the first in, first out manner. So here, the element 2 appears first time. So we have to add element 2 here. Then after that, the element 1 appears. Then after that, the element 5 appears and so on. Now, we have to remove the top element from the stack. So if we want to remove the top element from the stack, we have to remove the element 4. But wait, the element 4 is presented here in the queue. So we cannot remove any element from the queue in the back because it is strictly prohibited. We can only remove the element from the front. So how can we remove the back element of the queue? In this case, we have to take the advantage of the second queue. Here, the algorithm is pretty simple. We have to simply shift the first element, excluded the last element, into the second queue. So here, all the first element is 2, 1, and 5. So we have to add at first 2 here, now at first 1 here, now 5 here. So currently our first array or the first queue has only element 4 and all of the front element, which is 2, 1, and 5, shifted to the Q2. Now this element 4 appears at the first position of the Q1. So here we have to simply just remove this element from the queue. If we want to remove this element from the queue, we have to simply discard it. And if we apply the remove operations, simply the element 4 is removed from the stack. Now our task is half done yet. So as we removed all of the front element of Q1 into Q2, now again we have to insert all of the Q2 element in the Q1. So here we have to insert 2 at first, then 1 at second, and 5 at last. Now this order 2, 1, 5 is exactly equal to this order 2, 1, 5. But wait, the element 4 is removed here. So that is how we can implement the pop method in the queues, which will perform exactly similar to the stack. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, to implement the push method, we have to simply push the current element into the Q1. For the pop method, we have to first check whether the Q1 is empty or not. If our Q1 is empty, we have to return -1. Otherwise, we have to shift all of the front element of the Q1 except for the last element into the Q2 and remove the element top, which is the last element of Q1. And we have to again shift all of the Q2 element into the first Q1 to restore the stack. Finally, we have to return top, which is the last element of the stack. And in the top methods, we have to check whether the Q1 is empty or not. If our Q1 is empty, That means we have to return -1. Otherwise, we have to simply return the last element of the Q1. And in the empty method, we have to simply check whether the Q1 is empty or not. If our Q1 is empty, we have to simply return true. Otherwise, we have to simply return false. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.